anyway, so I've already given.
Okay. All right. So we've got two forms of equations that tangents can take on. Y equals mx plus b. And then there's this other crazy one that I don't like, which is basically what they call the point slope form of the line. And really what it is, you're calculating delta y over delta x. Okay. And you're equating it with m. And so you've usually got numbers in here for delta y and delta x. Anyway, you just rearrange this. Y2 minus y1 equals m times x2 minus x1. And this just simplifies into y equals mx plus b. Can you guys see that board okay?
Yeah.
That's a resounding silence.
Good answer, Griff. I thought.
Why did you think I was going to answer? Sometimes you got to take responsibility.
Because my microphone's off.
That's true. Okay. So let's find the tangents to y equals 1 over the square root of x at x equals 4. Okay. So when x is equal to 4, we can actually calculate our y coordinate pretty quickly. So it's actually going to be at x equals 4 and y equals 1/2. So if we wanted to put this in y equals mx plus b format, now we have our y and we have our x, but we don't have our b or our m. How are we ever going to find one of these two things? Any ideas?
No.
Ella?
No.
You're kidding. We're going to find m by taking the derivative.
Why would you think we were kidding?
You guys do that sometimes. Okay. Sorry, everybody. That's even messier than normal. We're going to find m by taking the derivative. Okay. So we're going to have to write way down here. So I'm going to rewrite this using exponential, using power notation. And so this is 1 over x to the exponent 1/2. So this is x to the exponent negative 1/2. All right. Y primed equals, if I asked you what the derivative was, what would you say?
Negative 1/2 x to the exponent. That minus 1.
That one right there. Yeah, exactly. Okay. Excellent. Okay. We need to find what the actual slope is at that point so that we can plug it in for our m. So y is equal to negative 1/2 times 4, which is our x value, to the exponent negative 3/2. So let's do this one piece at a time. Negative 1/2 and square root of 4. So that is 2 to the exponent negative 3. And that becomes negative 1/2. And 2 to the exponent negative 3 is 1/8. And so our actual slope is negative 1/16. Oh my goodness. Isn't that awful? So we have an x.
For y or for m there?
I beg your pardon? Oh, sorry, yeah. Those should be y primed. So if you're watching at home, you're gonna have to run it backwards and put your y primes in. So there's our slope, m. And so if we look back at y equals mx plus b, all we have to do is find b. Everybody ready? Got x, I'll just do this.
Oh,
We have y 1/2 equals negative 1/16.
I found it.
X is 4 plus b. All right, let's solve for b. We'll be done.
And go.
So b is equal to 3/4. So we're ready to find the equation of the tangent. It's just y is equal to negative 1/16 x plus 3/4. There's the equation of my tangent. So find the equation of the tangent always works out to be roughly the same thing. You know, you're given an x coordinate. You can find the y coordinate of the point. That point lies on the tangent. You can find the slope by taking the derivative. You can plug it into y equals mx plus b, or you can do the point slope form of the line if you like. Questions? Remarks? Smart aleck comments?
Why are you in Wyerton?
Why are you in Lion's Head?
Doing ELO there as well.
Yes, indeed.
Look at him go.
Beg your pardon? Well, we do. What's that? Well, they do, yeah. But I've got kids all over the board. Yeah. So I've got you guys here, and there's quite a little knot of you. So I'm here today.
Cute.
We're doing some quality physics. So Parker and Lauren, unfortunately, are sort of on the short end of the stick here because we've got the video conference in the middle of it. Okay. So we're going to find out where the tangent has slope equal to -4. Hey, what should we do? Any ideas? I take that clicking noise as meaning take the derivative. Can you guys still hear me? Yeah, you can still hear me. Okay, so there's our derivative. Okay, now the derivative tells us the slope at any point. So it's just a matter of plugging in the slope, and we're going to solve.
I don't want to yell at one.
Ayla, yell at him.
All right.
They should get it out.
All right, notice I've got a quadratic here, so I'm going to move everything over to the one side so I can actually solve it. Good so far? Going to factor out a negative so that I don't have to deal with negatives when I'm working with it. All right. What are the roots there?
I don't know.
So two numbers that have a product of -4 and a sum of -3. So -4, +1. If I expand that, I'm going to get the same answer here. And so the tangent has slope of -4 when x is equal to 4 or when x is equal to -1. Okay, I'm not going to do it here. But basically, if you wanted to find the complete points, you could find the y coordinates just by plugging those x's back into that equation. Sound good? I take your silence as yes. Okay, so Griffin, you're working on number 12 because you don't want to do 1 to 10.
Maybe I should just do 1 to 10.
Okay, so let's do a problem that's a lot like number 12. And,
Why are we beating around the bush here? Why not just do number 12?
Because you'll never learn, Griff. Never learn.
Yeah,
Oh, okay.
yeah. It's about the learning, Griffin.
I guess I
Okay.
can learn by seeing how it's
He
done.
doesn't want to steal your learning.
Frustrated, Ayla.
Steal the vibe.
Thank you.
Working with a chalk chuck here, it might be technology beyond my capability. Okay, we're going to find a tangent that goes through 0 and 2, and it's going to be tangent to negative x squared minus 2. Okay, I haven't located a meter stick yet, but we'll do a quick diagram here. It's going to be not nice and clean. 0 and 2 is up here. And what does this look like? What curve is that right there?
It's me, which is sad.
It's sad, exactly. And what's the y-intercept of the sad frowny face parabola?
-2.
Yes. Okay, so it's an upside down parabola, translated down to, there it is there. Okay, so now, when you look at this problem, we're looking for tangents that go through 0 and 2, and they're tangent to this, to that curve right there. How many of them are there going to be? 1, 2, more than 2? Ayla, take a guess.
I wasn't listening. I was writing. I was
Okay.
hoping Griff would jump in.
So there's one possible point of tangency there. Okay, and there's another possible point of tangency right there. So we've got 2 possible tangents. So when we get to the solution, we're actually going to be able to find 2 solutions. Okay, let's put that point as A. So it's got the x coordinate of A, and we don't know what the y coordinate is, right? So what we're going to do is we're going to put A into our equation. We're going to say it's negative a squared minus 2. Okay. We have to find the slope of this tangent, so let's just find y primed, negative 2x. So whatever A is, we're going to put it into this, and so the slope when x equals A is negative 2A. All right, let's do point slope form of the line, or let's another way of looking at it is calculating calculating the slope. So the change in y is actually negative a squared subtract 2, which is my y coordinate up there. Okay, so delta y, in other words, is 2 minus negative a squared minus 2. My delta x is, what did I do? Oh, I started up here. 0 minus, and my x coordinate is a. Okay, so I've done the slope backwards, but it won't matter. And that has to be equal to 2a. All right, so notice that we have, by equating the slope that we calculate here between these 2 points and equating it with the equation of the tangent at the point A, I'm going to get this down to a quadratic expression. And all I really have to do is solve for A. And I'm going to get 2 solutions. Make sense so far?
Yeah.
All right. Here's what I'm going to do so I can just spend a bit more time with Wade and Lauren is I'll let you guys figure that out.
Yeah, go figure it out, Ella. No,
No,
figure
Griff,
it
because
out.
I'm doing number 1 to 10.
Yeah, and I have to do number 12.
You have to do number 12. You made the commitment.
Okay.
So how do you get from there to the tangent line?
Okay, so you're going to find A.
Yeah.
You're going to find this point right here.
Mm-hmm.
And then that's going to tell you the slope just by plugging it back into the derivative, right? So negative 2a is going to be the slope of that line. And you'll also be able to calculate what the x and the y coordinate are just by plugging whatever you get for a into this.
Mm-hmm.
Okay. So there will be 2 solutions. Number 12 is pretty much like that, except there's a radical involved.
Yeah.
So
I'll try and go through the motions.
yeah, treat it as a quadratic-like expression. So I think it's something like a plus something square root of a. So just convert that square root into u, and then you'll wind up with u squared plus something u plus something. All right. Good luck, team.